Hi everyone, welcome back. You're watching Math with Anila. Today, let's discuss about the most important topic of matrices, that is matrix multiplication. First, let's see the compatibility for matrix multiplication. So, two matrices A and B can be multiplied together if and only if the number of columns of A should be same as the number of rows of B. That is what the condition you have to remember. Here we need to find the product A into B. So what was the condition? The condition was that the columns of the first matrix should be same as the rows of the second matrix. Look at the matrix A. Here how many rows and how many columns are there? Since it's a square matrix, this has equal number of rows and columns. Even in this case, the order is same. So the first, whenever we write the order, we write the columns into rows. Even here also columns into rows. As per our condition, number of columns. How many columns it has? It has 2 columns. And that should be same as number of rows of the second matrix, that is 2. So here both the columns and the rows are equal. Let's find the product A into B. Write the matrix first here. A, that is 2, 3, 4, 1. And the second matrix 1, 2, 3, 5. So let's start the multiplication. And first what you have to see is you need to consider the first row here and consider the first column. So the multiplication we do in this way. Write the row here and this is the column. We are considering the column of the second matrix. And you need to multiply the first element with the corresponding element here and the second element with the corresponding element here, and you need to add it. This is how the multiplication goes. So multiply 2 with 1. 2 into 1 plus 3 into 3. You will get the first element of the product matrix AB. Consider the first row, multiply the elements of the first column. Now if you multiply the columns of the second matrix, you will get the second element. And here again the same way, instead of 1, 3, we'll write 2, 5. Corresponding elements to be multiplied and added. 2 into 2 plus 3 into 5. 2 into 2 plus 3 into 5. We got the second element. So whenever we are keeping on considering the columns, you keep getting the elements of the columns. Since we have considered the first row here, we are getting all the elements of the first row. So this is the first row and here the element of the first column and here the element of the second column. In the same way, when you consider the second row, you get the elements of the second row. So second row, the elements of the second row are 4, 1 and the first column is 1, 3. Multiply the corresponding elements, you get 4 into 1 plus 1 into 3. And the next column when you consider, you get the element of the next column 2, 5. Multiply the corresponding elements again, 4 into 2 plus 1 into 5. So we got the product here. Whenever you consider the first row and keep multiplying each column, you get the elements in that way. First row and first column will give you the first element. First row, second column will give you the second element. Then second row, first column will give you the element of the second row as well as the first column. And second row, second column will give you the element of the second row and second column. Look at this. This is how you get the product. Now we have to just simplify. This is the main step you have to remember always. And when you multiply this, you'll get this as 2 plus 9, 4 plus 15, 4 plus 3, 8 plus 5. Just add and write it. You will get this as 11, 19, 7, 13. This is your product AB. A into B is matrix 11, 19, 7 and 13. This is what the multiplication of matrices. And what's the condition? You remember, always you remember, very, very, very important, that the number of columns of the first matrix should be same as the number of rows of the second matrix. That is the compatibility for the matrix multiplication. And when you multiply, we consider the row and multiply it with the column. This is how the multiplication process goes. Now let's find the product BA. B into A. How will we get? This is 1, 2, 3, 5 into A is 2, 3, 4, 1. Let's multiply it. As I have told you, consider the first row. First row is 1, 2 and first column is 2, 4. Multiply the corresponding elements here. You get this as 1 into 2 is 1 into 2 plus 2 into 4. And now when you consider the first row and the second column, you get this as 1 into 3 plus 2 into 1. Now consider the second row. When you consider the second row, it will be 3, 5 and 2, 4 is the first column. Multiply the corresponding elements and add it. You'll get this as 3 into 2 plus 5 into 4. And the next one will be 3 into 3 plus 5 into 1. As I have told you, once again you remember, when you consider the first row and the first column, you will get the element of the product matrix as the first row, first element, and when you consider the first row with the second column, you will get an element in the second column and it will be in the first row. When you consider the second row and the first column, you get the second row element in the first column, and when you consider the second row and the second column, you get the element of the second row, second column. This is how the multiplication process goes. Now just the simplification. We'll get this as 2 plus 8 and 3 plus 2, 6 plus 20, 9 plus 5. Add it. You get the product as 10, 5, 26 and 14. This is what the matrix BA you get. What was AB? AB was 11, 19, 7, 13 and BA is 10, 5, 26, 14. So what can we say from these two? AB is not equal to BA. AB is not equal to BA. See, in case of numbers, you can say consider number 35. 35 is 7 into 5 is also 35 and 5 into 7 is also 35. However you multiply, you get the same answer. But in case of matrix multiplication, you must remember that AB is not equal to BA. That means it is not commutative. Matrix multiplication is not commutative. Consider another question. Matrix 6, 4, 3 minus 1 into minus 1, 3. Here, two matrices are given. We need to find the product. Look at the order of the first matrix. That is 2 by 2. And in this case, how many rows are there? 1, 2 rows and 1 column. The order of the second matrix is 2 by 1. So we have to check whether the multiplication is possible or not. What's the condition? The condition says that the columns of the first matrix should be same as the rows of the second matrix. How many columns this has? This has 2 columns. 1, 2. And how many rows this has? This has 2 rows. Minus 1 and 3, 2 rows are there. Therefore, the multiplication is possible. Let's find the product. First, as I have told you earlier, you have to consider the first row and the first column. You get the first element. So it will be 6 into minus 1 plus 4 into 3. And we don't have the next column here. So there is only one element we get here. And the next row is 3 minus 1. With the column when you multiply 3 into minus 1. 3 into minus 1 plus minus 1 into 3. Minus 1 into 3. That is all the multiplications. Since this has only a single column, we will have only one column here. So look at that. This will be minus 6 plus 12 and this is minus 3 minus 3. That's equal to minus 6 and plus 12 is 6. Minus 3 and minus 3 is minus 6. This is your final answer. That is the product what you get here. Now you can solve this and let me know the product. Remember the rules here. What is the condition? The number of columns of the first matrix should be same as the number of rows of the second matrix. That's all for today. Let's learn more about the matrix multiplication in the next class. Thank you.